In this video, we'll continue our discussion of section 2.3, linear equations. We're going to work with IVPs, so we're going to find a solution, the particular solution, and then the largest interval I, no general solution here. Okay, so this is first order linear. I just need to put it in standard form. So this is dy dx minus 5y equals x. Right. These first problems, the method's going to be pretty straightforward because we're just working really on the IVP part. So this is e to the negative 5 dx, right? And that's equal to e to the negative 5x. So there's my multiplier. I'm going to multiply it by both sides. That's going to give me d dx of e to the negative 5x times y. And then I have to multiply the other side by that same thing. Right? Our integration here. Right, the left side's nice and easy. The right side, not so easy, but I can see that I have a vanishing term. X is going to vanish after a while, meaning the derivative goes to 0. So I'm going to use tabular here. So here's my table. Right, remember this is plus or minus, derivative, and integral. So plus, minus. This one goes away pretty quick. X goes here. Remember the vanishing term, 1, 0. And then e to the negative 5x is going to be negative 1/5 e to the negative 5x, and then 1/25 e to the negative 5x. All right, so remember the way we do these, it's this times that plus this times that, and then we're at the 0, so it didn't matter. It's going to 0 out after that. So we get e to the negative 5x times y equals, and it's going to be negative 1/5 x, don't forget that x, e to the negative 5x, and then minus 1/25 e to the negative 5x plus c. This one cleans up pretty nicely, right? E to the 5x goes through, and I get negative 1/5 x minus 1 over 25, and then plus c e to the 5x. Now we're going to use the condition that was given to us, which was y of 0 equals 3. So I'm going to plug this in. 3 is y, and then negative 1/5 times 0 minus 1/25 plus ce to the 0. So this is gone. E is a 1. So I get 3 equals negative 1 over 25 plus c, which means c is, that's a 75 over 25 plus 1, 76 over 25. And then we have our solution. So y equals negative 1/5 x minus 1 over 25 plus 76 over 25 e to the 5x, right? And then this thing is defined. I don't think we divided by anything at any point. Our function doesn't have any weird continuity problems, so I is negative infinity to infinity. So there we go. We have the actual solution, particular solution, because it was an IVP and we were given an initial condition. So there's our whole solution right there. Okay. We're going to do two more IVPs. I'm trying to pick some of the weird ones. This one usually trips people up, so I'd like to work through it. A lot of variables, K's or parameters, K, T, T, M, T, not. Those are all just positive or constants. We don't know if they're positive. So our independent variable here is T. So to get it started, I'm going to go ahead and multiply because I see that this is going to have a K capital T. That's my only dependent variable. And then this is going to have a K times Tm. I can put this into our linear form by moving the kt over, because that's our y in this case, and then I have a negative ktm. Cool. All right. If I had to find mu, okay, mu is going to be x e to the integral of negative kt dt. So that's e to the negative, hold on, something. Oh, no t. I was like, wait, it's different than my notes. Just a k. We don't take the t with us. So this is an e to the negative k t. So I'm going to multiply both sides, but remember we can just jump straight to the product that's over here because it's a product rule. E to the negative k t, capital T, times capital T. This is lowercase t. It's our input. I don't like this capital T and lowercase t. I hate it. I would have chose something else. Okay, so and then I have to multiply this side also by that, so it's going to be negative k t m e to the negative k t, right? If I integrate, that comes out. And then most of this is a constant. But remember when I integrate e to the negative something, like e to the negative kt, if I just were to integrate that alone, I get negative 1 over k e to the negative kt. That's I introduced that net 1 over k. So I'm just going to introduce that negative 1 over k here to do that. And it's going to cancel with that negative k, leaving me with just a tm e to the negative kt. K and tm, I just added that on to this, right? Negative k tm. The negative k cancels with the negative 1 over k, leaving me with what I have. All right, if I'm moving forward now, don't forget plus c, all right? And we get capital T of little t is going to be equal, and we're going to multiply everything by e to the kt. I get a tm plus c equal e to the kt, positive, right? The initial condition they gave us here was t of 0 is equal to t naught, just my initial. We're not going to get a satisfying answer here, but luckily the work isn't too bad. Uh, I'm just going to plug in t naught into y, and then I get tm plus c e to the 0. Little t was 0. That means that I get t naught equals tm plus c. So c is equal to t naught minus tm. And then now we have our actual solution. So we're going to write it down. Tm plus, and I'm going to put this in parentheses, t naught minus tm. That's my c equal e to the kt. This, I didn't divide again by anything that could create a 0. So I is across all real numbers. So there's my solution to the second one. Don't let constants like tm and stuff like that bother you. You just keep them. It actually, I think, kind of makes the work easier to do, but it looks really daunting. Looks confusing. All right, one more here, and then we'll move on into the weird topics of this section. There's like 3. All right, we have this right away. We have first order linear, so that's great. I can start right away with mu. That's e to the negative integral of sine x dx. That's e to the just pretty cosine x. That negative is what made it that. Okay, so I'm going to multiply everything by that. So d dx gets me e to the cosine x times y. I don't even think about multiplying that out, making it the product rule. I know what's going to work out. Okay, and then I got to multiply 2 e to the cosine x times sine x. All right, our integral. All right, I got a 2 out front. E to the cosine x times sine x dx. Okay, and what that's going to produce, if you do u sub cosine, then du is going to be negative sine. So we get e to the cosine x times y, and that's going to equal, okay, you can just kind of imagine, I'm just going to have an e to the u. So I get a negative 2, and then I'm going to have an e again with cosine. All right, you could take the derivative of that and see that it works. Don't forget plus c. Okay, y equals, and I'm going to divide by e to the cosine x. So I get negative 2, and then plus c e to the negative cosine x. That brings it to the top. Okay, our initial condition. So I'm going to plug that in. 1 equals negative 2 plus c e, and then negative cosine of pi over 2. And I hope your trig is strong. Cosine of pi over 2 is a 0. So we get negative 2 plus c, which means c is 3. And then we actually have our answer. Negative 2 plus 3 e to the negative cosine x. And then the I think, what did we divide? No, we never did. Everything with the sines and cosines had the e above it, meaning it's not going to be a 0 ever anyway, because if the cosine or sine are 0, e is 1. E to the 0 is 1. So there we go. So IVPs are about the same. You just got to find the c in the end, which is pretty straightforward.